Hello, and welcome to the Millersville University Office of Learning Services presentation on memory strategies. Today, we're going to be talking about and defining different types of memory, reviewing the brain structures involved in memory, and then we'll wrap things up with some tips to help you improve your memory. These are the different types of memory that we'll be reviewing. This includes short-term memory, long-term memory and all of its subtypes, visual and auditory memory, and finally working memory. Short-term memory refers to memories that are held for a limited amount of time. This occurs through a process called working memory, which helps us hold on to information to manipulate it until we no longer need it. What are some examples of short-term memory that you can think of? This could include things like following directions, remembering a phone number for immediate use, or just keeping numbers in your mind to complete a math problem. Long-term memory has a much larger capacity and refers to information that can be recalled after longer periods of time have passed. Some examples of this type of memory include your home address, your home phone number, or where you attended elementary school, for example. There are a few subtypes of long-term memory that work together. These include episodic, semantic, procedural, and implicit memory. Episodic memory refers to the memory of past experiences, like maybe a fun birthday party or a wedding. It could be helpful to think of these types of memories like an episode. You can almost watch back the birthday party in your head. Semantic memory involves memory of factual, non-personal information. For example, do you happen to know the name of the capital of the United States? Procedural memory refers to memory for learning actions or behaviors like walking, dressing, driving, riding a bike. And then lastly, implicit memories are memories that we have that we're unaware of that impact our actions and choices. So for example, we know not to touch a hot burning stove because perhaps when we were a kid, we learned this by touching it and burning our hand. And then that association was built, and now we have that implicit memory. Visual and auditory memory are two types of memory often talked about together because they have similar processes referred to as the visual sketchpad, visuospatial sketchpad, language sketchpad, and the phonological loop. The visual sketchpad refers to the process by which our brain maintains an image of what needs to be done. For example, can you think of how to make a bowl of cereal? Your brain likely can produce images depicting each step in the task that must be completed. Similarly, the visuospatial sketchpad maintains images of the task as well as their location in space. Has anyone ever forgotten, perhaps, where you parked your car at the mall? In addition to these visual systems of memory, we also have the language sketchpad and the phonological loop. The language sketchpad remembers speech sounds in their temporal order. For example, if I asked you to repeat the word marshmallow, you can most likely repeat the word with all of the correct sounds and in the correct order. Similarly, we also have something called a phonological loop. This is an inner voice that repeats verbal information. One common example of the phonological loop is repeating a phone number that someone gives you in your head until you have a chance to write it down. By doing this, you're essentially holding the sounds of the numbers in your mind through internal rehearsal. Now, what is working memory? Well, working memory is the ability to store a small amount of information for use in the short term, facilitating tasks like planning, comprehension, reasoning, and problem solving. Working memory allows us to hold a plan of action while simultaneously calling up items from the rest of our brain for immediate use. Working memory is incredibly important for a variety of tasks like following directions, understanding questions and answering them, doing mental math, reading, paraphrasing, and many other important tasks related to academics. Anytime you're processing, using, or remembering information, you've employed working memory. To ensure that we're using our working memory optimally, we must be aware of its limitations. Working memory is a limited capacity system with an average of 5 to 9 items. You may have heard about this before as the magic number 7, which is a reference to a famous study that suggests that the average a person can hold is about 7 items in their working memory, give or take 2. Once you've exceeded your working memory capacity, you won't be able to remember as much information. This is why taking breaks when studying or working on homework is so important. It gives your memory the chance to reset on its own before it becomes overloaded. It's important to note that working memory is a process that falls under the umbrella of executive functioning. Executive functioning involves planning, organizing, problem solving, retrieval, self-control, and self-awareness. Working memory and executive functioning are very strongly correlated and are both related to attention. Those with attention deficit hyperactivity disorder, otherwise known as ADHD, often perform somewhat worse on working memory tasks. This is a disorder of executive functioning. It's time to see our working memory in action. I'm about to read some numbers aloud, and what I want you to do is say them back in order from smallest to largest. Are you ready? 5, 3, 9, 2, 8. Go ahead and pause this video if you need to see if you can put those in order. Here's the answer. If you were able to successfully manipulate the order of the numbers, then you just used working memory to manipulate information to complete a task. In fact, your working memory was active in more ways than one. First, you were attending to the directions and the numbers, holding them both in your mind long enough to know what to do with them. Additionally, the language scratchpad was likely active to repeat the numbers so that you did not forget them. Your working memory also called upon information that was stored in long-term memory to recall number order and help you successfully put the numbers in the correct order. And lastly, your executive functioning system helped define the relevant knowledge in that long-term memory. Now take a moment. How do you think the memory types that we've reviewed are relevant to school and learning? Think about completing math problems, recalling factual information at appropriate times, such as on a test. Maybe you have to think about relevant experiences to connect with new information that you're learning about in class. You have to remember and follow through with directions on assignments pretty regularly. Think about everything required when you're reading to know the words in front of you, string them together, remember what was said previously, the context of everything, relating it back to yourself, feeling the emotions. All of that has to do with memory and your learning in school. It is now time to check your understanding and put your own memory to the test. Please take a few minutes to look at the practice questions in the provided handout. List what types of memory you think are involved in each question. As a hint, there can be more than one. Please pause the video to complete this activity. Now we will review some brain structures that are highly associated with memory. The thalamus is a key brain structure involved in memory because it directs our attention, assists with the formation and storage of memories, helps us learn, and is involved in processing sensory information. The thalamus can be described as paired, egg-shaped structures that sit side by side in the center of the brain. The parietal lobe is associated with spatial memories, such as episodic memories that involve spatial components or the visuospatial sketchpad. This part of the brain is responsible for holding a map of our body and our position in space, referred to as proprioception. The caudate nucleus is associated with memories of instinctive skills, also called procedural memories. If you remember from before, these include walking, eating, grooming, riding a bike, and more. Mammillary bodies are associated with episodic memory and are associated with both memory and emotion of specific events called recollective memory. The frontal lobe is considered the seat of working memory because it houses the prefrontal cortex, a structure that is largely responsible for the various functions of working memory, like directing attention, holding information in the mind for later manipulation, and recalling relevant information when necessary. The frontal lobe and the prefrontal cortex are some of the last brain structures to develop, supporting the idea that they're responsible for more complex, higher-order thinking and information processing. The cerebellum, also called the little brain, is associated with conditioned memories and procedural memory, though its main functions are the coordination of movement, including fine motor skills such as balance and posture. Multiple parts of the brain experience increased activity when learning to write, including the cerebellum, which is involved in the fine motor skills needed to produce writing. Similarly, to produce sounds when reading, the cerebellum is active. The hippocampus is involved with encoding experiences into memories, also referred to as memory formation. Additionally, it's involved in memory recall and spatial awareness. The hippocampus does this by selecting pieces of information to memorize and sending them to long-term memory areas of the brain. Damage to the hippocampus produces an interesting problem. Individuals can recall information that has already been encoded to long-term memory, but they may be unable to form new memories. The temporal lobe is associated with semantic memories, which you may remember from previous slides, is the type of memory that allows us to recall words, concepts, numbers, and other items to help us understand language. For example, your temporal lobe has been quite active through this workshop as you match words on the slides to their meanings by retrieving different memories. The amygdala is involved in many hot emotions, such as fear, as well as memory consolidations of emotional experiences. Memories are broken into distinct parts or categories, and different brain structures are associated with the component that initiated it. Since the amygdala is responsible for the certain emotions, the emotional component of a memory may be stored here. For example, because the amygdala is situated close to the olfactory bulb, responsible for processing smell, it can recall emotional memories associated with the smell. Lastly, the putamen is associated with procedural skills and the reward system. Have you ever heard of muscle memory? This deeply ingrained type of memory for movement is stored in the putamen. Do you know how to ride a bike? When was the last time you rode one? Even if it's been quite some time since you've ridden a bike, you could probably ride one today without any problems, thanks to the putamen's storage of these unconscious procedural motor skills. The medial temporal lobe is another structure associated with memory. It encompasses many of the specific areas we have already discussed, such as the hippocampus and the amygdala. Working together, they play an integral part in memory and emotion. For example, it's associated with short-term to long-term transfer, otherwise known as encoding. It encodes, consolidates, retrieves, and reintegrates facts. The anterior system is more involved in object and face recognition, conceptual identity, salience. Then the posterior system focuses on seeing recognition, location, trajectory, temporal context and order, and situations. Now we'll review some tips to help you improve your memory. The first technique is called visualization. To do this, you must try to see the item that you must remember in your mind. The more absurd you make the image, the more likely you are to remember it. For example, if you go to the mall and you park your car on level C in space number 5, you might imagine that there are 5 cats waiting in your car for your return. The cats are a prompt to help you remember the level C, while the 5 is to help you remember the space number. Try and think of some other examples. Technique 2 is called chaining. Chaining is a form of visualization to help you remember several items in order. For this technique, you must link the items together by thinking of images that connect them. For example, To remember shoe, piano, tree, pencil, you might imagine a chain of images kind of like this. Remember, the more absurd the better, like that piano wearing shoes. Technique 3 is called Place It, or the method of loci. This method is very similar to the chaining method, but it has a special twist. For this technique, the items to be remembered must be linked to specific places in the order that you would visit them. This was devised during the Roman Empire. The method of loci refers to the Latin word for place. This technique combines visual and spatial memory. More recently, it has become known as the memory or the mind palace. Think about if you visit a friend's house. You have to remember where you park your car and where you put your coat when you got inside. It's much easier to remember that you left your car one street up next to the yellow house and that your coat is over the chair in the living room because they are permanent items tied to actual places. The memory palace works in the same way. The first step is to think of a place that you know very well, such as your house or maybe your favorite park. You're going to select 4 to 5 main items in the room, keeping them unique to that room. So my items could be a rug, a painting, a chandelier, a table, a sink, and a refrigerator. Then you're going to determine your route, or in other words, this is just numbering the items. For example, in my house, I walk in and immediately see a colorful rug and a painting on the wall. I go through my dining room with a chandelier and a large table, into my kitchen with a sink and a refrigerator. Then you're going to add the information you want to remember to the permanent items. This would be coming up with a visual representation for the thing that you're trying to remember and associate it with those items. Then you create as many as you need to help you remember whatever it is that you're trying to remember. Technique 4 is called chunking. Have you ever wondered why phone numbers are broken down into 3-digit numbers followed by 4-digit numbers, rather than just one whole 7-digit number? Social security numbers are similar. Rather than remembering 9 digits, we must remember a 3-digit number, followed by a 2-digit number, and then 4 digits. These numbers are much easier to remember in the smaller chunks. The same can be said for other pieces of information. Breaking things down into chunks can make them easier to recall. Lastly, technique 5 is called acrostic it, which makes use of catchy phrases that use the first letter of a word to remember it. For example, when students are taught to read music, they may be taught the following. In treble clef, face can be used to remember space notes, and every good boy does fine helps remember line notes. In bass clef, you could remember all cows eat grass, and good burritos don't fall apart. Can you think of any other examples? Have you ever heard, "Please excuse my dear Aunt Sally," or "Sokotoa"? What about Roy G. Biv? Or "Never eat soggy waffles"? Here are some other things to think about. Sleeping is important to ensure your brain has a chance to consolidate your memories. Incremental rehearsal refers to slowly adding in new information while reviewing known information to avoid overwhelming yourself with too much new information. For self-instruction, think about if you can teach yourself as if you're teaching someone else you know that you've mastered the material. Self-regulated strategy development includes many of the mnemonics we've already talked about, picture cues to add a visual component, checklists, and task analysis. This is similar to dispersed learning, where you break a task down into manageable chunks and then you tackle them over time as opposed to all at once. It is important to keep in mind that these strategies are only helpful in the context in which they are utilized. With practice, these tips can become skills that are readily available to us to be used in our classes and whatever other areas of life we may need them. That concludes our Memory Strategies workshop. Thanks for tuning in.